Hey, sports fans. This quarterback draftability assessment was done by Chance Longo and John Shirley. Football is one of America's favorite sports to get behind. Ask anyone around you who their favorite football team is, and they'll have an answer. With the popularity of the sport, it is not uncommon for major NCAA programs to generate over $100 million in revenue in a single season. As impressive as that sounds, in 2016, the NFL earned more than $13 billion. So obviously, there's a lot of money to be made or lost based on a team's performance. With modern advances in fitness, nutrition, exercise science, and technology, there are now more ways to tune and improve the performance of football players on both the college and professional level. This has made the average player much bigger, faster, and stronger, and the expectations that much greater. As a coach, executive, or manager, these things make it more difficult to know which player could have a positive or negative impact on your team. Our business takes a similar approach like the one taken by Billy Beane, a former general manager for the Oakland A's baseball team, by testing to see if data mining could assist a team in ensuring a wise investment in a player based on their college performance. We decided to focus on the quarterback position of the football team. A team's quarterback, or QB, is the leader, decision maker, and play executor. These characteristics are the reason the position has been appropriately nicknamed the field general, and is often filled by what programs call a franchise player. It is a position that can either make or break a team's opportunity to win championships. He can either be the hero or the scapegoat for a football team's entire season. We thought that by assessing the QB rating, pass completion percentage, touchdowns, interceptions, and other statistics from a player's college career and correlating it to their professional career could show possible relationships among the data. By seeing these relations, it would make the decision of who to draft easier and provide necessary data to support the decision. This would give many owners and fans confidence in a team's choice and odds to prevail throughout the future seasons. The data we used are the passing statistics for current NFL quarterbacks from 2012 to 2017 and their previous college careers. Some of the variables include pass completions, pass attempts, completion percentage, total yards, average yards per attempt, average yards per game, touchdowns, interceptions, and quarterback rating.
Okay, thanks, John. Again, my name is Chance. I'm going to be taking you through the analysis portion of our study here. I want to thank John for giving me such a nice clean data file. As we know, it's about 90% of data science, and it made it a lot easier to do my job on this end. To start off, I want to direct your attention to the right-hand side of the screen. I think when we go about analysis, of course, we always have to go ahead and keep our goal in mind. What are we trying to do? And we're trying to go ahead and predict NFL success, specifically of players coming out of college, before we really know anything about them. Once they're in the NFL, of course, we have a whole body of work to look at, and we can expect that they'll continue to perform in a similar way, maybe perhaps dropping off a little bit as they get older. So we're building a selection system here. Okay. What we are really doing is what's called a concurrent study as opposed to a predictive one. And most studies in selection are concurrent studies. We can go ahead and we can look at our incumbents' performance appraisals. And we could go ahead and look at some things we might have known about them before they got into the job. And then we could go ahead and build our selection system based on that. Maybe perhaps GPA or something, went ahead and predicted success on the job. All right, at least that's what we can find in our analysis. Then we can build our selection system around that. And it doesn't matter what you're selecting for, right? Customer service representatives, sales people, engineers, all right? You can build a selection system here in a similar way. Because we have so much data coming in, perhaps sports will be a little bit easier. We'll find out here in a second. start over on the left-hand side then. Our independent variables, also known as our predictors, or as data miner calls them, our inputs. In this case, we're going to look at a lot of different college statistics that we have from people. You see some examples listed here. All right. I went ahead and I reduced our scope a little bit as we did our analysis. I'll talk about that a little bit later. So we ended up only using interval variables here. All right. On the right-hand side, there's our dependent variables, also known as our outcomes, or in data miner, you know them as targets. All right. Some examples of those here. Again, all interval variables as well. Right, makes life a lot easier. Of course, if we're going to call this data mining, we usually end up with a whole bunch of variables, especially on the input side here. All right, let's move on. All right, here you see a whole big list, again, a lot of variables of our descriptive statistics here. All right. Once you have a clean file, of course, I think one of the first things you do, always the first thing you want to do, is to look at the descriptive statistics. And this is a screenshot here. It's a little bit hard to see. All of our inputs are listed on the top part of this screenshot, and on the bottom part we have all of our targets. Not too many remarkable things to look at here. I think a visual is going to provide more information for us. We do have some minimum scores in areas such as college touchdowns is 0. That stands out to me here. College interceptions, only 1 for a player. You can go ahead and kind of get an idea without looking at the graphs of the distribution, see if it's normally distributed or not by looking at that skewness column. You can also go ahead and compare the medians and the means, look at the difference there, and you can get an idea whether it's normally distributed or not. All right. Now we went ahead and we investigated this. Here's some variables that popped out and are later on going to be important to us. So here's our histograms. I always like going ahead and taking a peek at all the visuals. Sometimes you can go ahead and identify things. Of course, just a list of numbers doesn't help you find. Up top here we have our target variable. This is average quarterback rating in the NFL, right, or what becomes our main target variable. Right. Somewhat normally distributed. Keep in mind with all these, our N is not that high. We have 55 players that we're looking at, and with such a case, I think you have to have some flexibility as far as looking at these distributions. They're not going to be perfectly normally distributed. Of course, nothing is. Here's some predictors down here at the bottom. They seem to either make sense or they ended up kind of working a little bit better in our models. Over on the left-hand side, college touchdowns. All right, simply a number of how many college touchdowns does somebody throw. Very normally distributed here. In the middle, college quarterback rating. This would seem to be an obvious predictor, all right, because we're trying to predict NFL quarterback rating. Why shouldn't they be the same? Very normally distributed. And then over on the right-hand side, we have our college passing yards per game. And one that really stands out here is this one outlier. I kind of have it highlighted already. This seems to be very different than everybody else. If you look on the scale here, it's only one single case. There's a couple ways we can go and handle this outlier. You can go ahead and handle it individually. All right. Now this would be a pain in the butt if you had a lot of these to take out. You could go ahead and set upper and lower limits on your variables if you click on the miner when selecting your variables. Or you could go ahead and use a filter node, which is probably the easiest way of doing it. It goes ahead and filters out cases with extreme standard deviations, all right, z-scores of probably plus or -3. If it's beyond that, it's going to get rid of cases like that. We tested with and without the filter node to see if that made a difference. Let's go ahead and move on. So just to review our steps up to this point, we import our data into data miner, went ahead and looked for missing cases in our variables. We ran our descriptive statistics, and the point of that, of course, was to look at the normality of our variables, and with a little help from those histograms as well, and from our max and min, we went ahead and identified some outlier cases, and we ran with and without a filter node to go ahead and take care of that. In the end, we didn't see many differences. All right. The next step is to go ahead, since we're doing predictive statistics, makes sense to go ahead and look at our bivariate correlations. So up top we have average yards. Down below we have the what becomes our target variable of interest, average quarterback rating. I do want to point out on the slide, these cases over on the far left are kind of our best correlates. These are actually NFL stats. All right. And anything with C in front of it is a college stat. I need to eliminate a few more here. Okay. As I've mentioned at the beginning of this slide, of my portion of the slideshow, obviously once they're in the NFL, their stats are becoming a lot more predictive of how they're going to play in the future. But again, we are building a selection system to draft players, so we're just going to look at the college stats here. And for these variables, we're looking at a correlation of about 0.3 over here, a little bit lower in the 0.2 range. That's not a very strong correlation, right? If you're familiar with stats at all, we can tell we have a few problems head our way here. Let's take a look at a few more targets very briefly. Two more potential targets here. All right, we have up top yards per game, all right, in the NFL, of course, and first down percentage. Not much to talk about here. All right, Data Miner, of course, provides these correlations. Sometimes they're a little bit better viewed in a matrix style. All right, very weak correlations in the 0.2 to 0.3 range. All right, let's move forward. So not surprisingly, as you see a frowny face here, no one likes to see this as a statistician. We didn't get very good results. In other words, we weren't able to predict much here. You could go ahead and take a look at what we did. I'll explain all of those a little bit more in depth later. Of course, all the models that we looked at kind of came up with the same results. All right. We found only one significant input, all right, and that was surprisingly college yards per game. All right, but even that wasn't that strong. So the main problem, or the main cause behind not finding good results here were the weak correlations across the board. Here's our strongest correlate, strongest relationship is between college yards per game, again, and average quarterback rating in the NFL. All right, and I really don't need to do this, but you can just kind of draw a big circle around these. This is not very predictable. All right, let me draw kind of a best fit line with the eyeball method. We can see some rather large residuals here. I'll talk about that a little bit later when I talk about R squared versus mean squared and mean squared. All right, let's go ahead and look at decision trees then. All right, just a couple quick visuals on decision trees. All right. It doesn't make a whole heck of a lot of sense here, since we are kind of coming down to maybe perhaps a dichotomous outcome, binary outcome, if you will, select or do not select for the NFL. We use college yards per game over here as our predictor, our one significant one in the final model, and it says to go ahead and select for people with more than 212 yards per game. Do not select for 212 yards per game or less. Over here, this is kind of what you can expect, or the difference right here between the two cases. You see a little bit of a jump of average quarterback rating, but it's really not that much. Seeing something like this, you'd probably say, is it really worthwhile to go ahead and use this as a predictor? Well, I'll talk about that in our conclusion. In our next attempt to create a useful predictive model, I moved on to the stepwise regression. And first I want to go ahead and point out all those tools that you see in Data Miner, they all are doing a very similar thing. Right? Again, we're building a model in pretty much every case up there, even if you haven't learned about some of those. Some of those tools are better suited for binary dependent variables. Some are better suited for ordinal dependent variables. Here we have an interval one. Makes a lot of sense to go ahead and do a linear regression. All right, stepwise linear regression. Let me talk about that for just a minute. You have a few options here. We are doing stepwise, but you can do a forward way of building your model, in which your independent variables are added to the model to see if they improve it at all. It goes in line of the correlates. Backwards, where it takes off your poor independent variables in your model until it builds the best total model. All right, stepwise does a little bit of each, but also keep in mind that these are helpful tools, but it does not test, stepwise regression does not test all possible combinations of independent variables here. All right, it's a method, it's helpful, but it's still possible that there could be some combination out there that somehow would yield a better result than what we see here. And it's also why we test our models in many different ways. All right, so obviously we're hoping for some sort of multiple regression here, and what we end up with in the end is a simple linear regression. All right, the best model we could find was with only one independent variable added. All right, bear in mind this is better than our other attempts with other targets. They would not add any independent variables, so other models for predicting other NFL stats were completely useless. In this case here, we have college yards per game. This fit our model. This was a significant result. So quite simply, just like we saw in the decision tree, if we go ahead and take into account how many yards per game someone passed for in college, it's going to give us a better idea, maybe perhaps of what kind of quarterback rating they could have in the NFL. Next, I want to go ahead and draw your attention to how I went ahead and looked at this model. Down here at the bottom, we have R squared and adjusted R squared. Adjusted R squared goes ahead and takes into better account how many independent variables you actually have here. So you see that number is a little bit lower in this case. Okay. You have options when evaluating models. In our class, we went ahead and used mean square error quite often. Probably a standard would be root mean square error. And that's really looking at how off your predictions are. Root mean square error is going to go ahead and punish you a lot more when you're really off with a prediction. And with the correlations that we saw earlier, we saw that some of those correlates were pretty bad. We're going to see some bigger residuals here, especially with the smaller n. It just makes a whole heck of a lot more sense to use adjusted R squared. As this number gets larger and larger, we are explaining more and more of the model. We're explaining more and more of the variance. So we're hoping for a high adjusted R squared. What we have here, 0.0 or 0.1, that's really pretty poor, actually. I can't really tell you what number to look for. It's going to depend on what you're analyzing. A good rule of thumb might be to say I want to adjusted R squared of at least 0.5. Right? Some people would say you want to towards 0.7. If it gets too high, you're probably overfitting. Okay, but I used adjusted R squared for all of these analyses. Let's go ahead and move forward. Since we didn't have significant results here, I wanted to go ahead and take a break for just a minute to go ahead and draw attention to something that might not have been well covered in some of your graduate level statistics classes. Take a look at this picture over on the right hand side. Over here, we have college yards per game. We see a correlation between that and our target variable of NFL quarterback rating. But you also notice that we have a very similar correlate right here, right? And that's college touchdowns per game. As a matter of fact, almost the same correlation to our target rating. And big question is, of course, if they're so similar, why wasn't college touchdowns added to our model? Well, let me go ahead and break that down. You need to think about what is actually happening in multiple regression. Today, I think we go ahead and we skip forward to when to use multiple regression, how to use it within a program, and we don't dig deep enough into what is actually happening with our variables. Well, in simple linear regression, of course, we have our target, our y, and as predicted by just one variable by itself here to x1. But with multiple regression, of course, we are adding perhaps an infinite number of other independent variables or other x's to our model. And those are all going to come together to predict y. Right? Now, as often is the case in real life, our independent variables are going to be correlated with each other as well. And when that happens, oftentimes we end up with variance that is explained by both independent variables, this section here. So when we have two independent variables that are correlated with each other, it may be the case that one variable is not really adding anything new to the model. So when stepwise regression goes ahead and keeps adding variables to the model, when it goes ahead and adds x2 here, right, nothing new is added. If anything, it only muddles the case and actually makes our adjusted R-square worse. Right? So think about it in this way. Two things that are perfectly correlated with each other, say Fahrenheit and Celsius. Right? What we'd see in that case is x1 and x2 both perfectly overlapping each other. Now, if you were trying to predict something like how many people would show up to park one day based upon temperature, if you had our temperature in Fahrenheit, you can make your prediction, simple linear regression. But if you go ahead and say, well, maybe we can get Celsius too, well, Celsius isn't going to add anything, right? They're perfectly correlated, they're the same thing. It's pointless to go ahead and consider Celsius and Fahrenheit in predicting how many people are going to go to the park. And this is exactly what's happening here with college yards per game and college touchdowns scored. Over on the left-hand side here, did this in Enterprise Builder. We have the correlation between our two independent variables, very strongly correlated at 0.75. See how significant that is. And what I would suspect is something that looks like our diagram over on the right-hand side here. All right. X2 is only bringing in the same variance it's already explained, so it's actually only making the model worse. Okay. Let's move forward. Parallel axis diagrams are a helpful visual tool to go ahead and understand the relationships between a couple of variables. Sometimes it's the problem with cases of high end, and they get a little bit muddled and hard to read, but you can go ahead and look at them for patterns. Variables are correlated when you see a lot of these lines here between two variables going the same direction. In this case, we see a lot of lines moving like this, showing that there is some sort of correlation. Again, we have fairly low n here, and some of these lines moving in a different direction. That's what's actually causing a lower correlation here. Over here, we see the relationship that's very strong between college touchdowns and college yards per game. So we see a lot more of these lines all moving the same direction. Right. Now, to actually make use of this and to demonstrate what I was talking about on the last slide, you're better off going ahead and standardizing your variables here. You can do that simply with a transform node in Enterprise Miner. It's very easy to do. Then go ahead and hook it up to a graph node, and you can build something like this. Now, in this case, when you have a straight line like this here between two variables, that's going ahead and demonstrating your correlation, and that's why, of course, you see a lot more straight lines here. Now, if adding another variable is going to be useful to building our model, what you're going to go ahead and see perhaps is more of an angled line like this result over here. Okay. In this case, our bound variable here, college touchdowns, does a much better job predicting. I'm going to mark it here on the graph. Does a much better job of predicting our target NFL quarterback rating than college yards per game did. All right. In this case here, kind of outlier, this did a poor job of predicting it. And when you have more cases like this popping up, that would suggest that then our additional variable could go ahead and add something to this model. But in most cases, we see a lot of straight lines going all the way down, meaning that this variable here, all right, our best input, college yards per game, is doing just as good of a job as predicting NFL quarterback rating as college touchdowns did. So in that case, it'd actually be pointless to go ahead and add college touchdowns, which in this case actually did happen. Let's move on. My last attempt to create a useful model here involved using least angles regression, sometimes known as LARS. Of course, you have the lasso option in there as well, and you find it in the same place that you find other regressions in data miner and decision trees as well. And in some cases, it can go ahead and help. I really didn't expect it to. Our bivariate correlations were so poor across the board. Whichever model you try to build, it's probably not going to work. In some cases, with a lot of variables that are highly correlated to each other, of course, we're talking about independent variables. For example, our case with college touchdowns and college yards per game, sometimes this can go ahead and help us a little bit, can find a little bit of a different way to build something a little bit better. Really, there's only two good independent variables there, so I really didn't expect much. We're talking about when you have a whole bunch of correlated variables, where maybe perhaps stepwise regression would miss something. All right. So in this case, I did a little comparison at the end. I got the same kind of R squared. The adjusted R squared was about 0.1, R squared 0.11. That's right here. And just for the sake of showing this point, I went ahead and I forced college touchdowns into the model as well. And as you can see, it actually reduces R squared. So it makes the situation worse. Right. So yes, we're sad we didn't get significant results, but it happens in real life. And even getting non-significant results really tells us something. Right, in this case here, we can't use college statistics to predict NFL success. These are exactly the steps that you'd want to take in creating a selection system. And I promise, of course, people and consultants, NFL teams have actually gone through a similar process to this in the past. All right, so let's take a quick look at some of our conclusions. Of course, college statistics don't predict NFL success. So obviously, there's some latent factors out there that might help us better understand NFL success. That's why we run the combine. That's why teams bring in players and go ahead and interview them and try them out themselves to try to learn a little bit something more about them and predict how they're going to do. And obviously, teams have still not figured this out. My Chicago Bears have had about 80 quarterbacks in the last 25 years, and none of them have been successful. It's been sad. So no one's really doing a great job at this yet. Maybe in the future we will go ahead and find some things that really predict NFL success. All right. So we can use passing yards per game. Right. It's not really going to help us that much. I couldn't really recommend making a real decision about whether to draft someone based upon that simple fact. There's plenty of quarterbacks, I'm sure, pass for plenty of yards out there, and they never even get drafted. So to conclude, one day we'll be able to go ahead and predict maybe perhaps the next Peyton Manning or the next Tom Brady out there. Right? It takes time. We're going to continue to improve the model over years. All right, you can bet that NFL teams are continuing to collect data, and again, that's back to why we call it big data. We keep getting more and more information in, and we continually improve the model over the years. And I think you're going to continue to see NFL teams employ these scientific methods, and even more importantly so, you're going to see businesses and companies continually try to improve their selection methods. We've seen a lot more in the past 20 years. You have recruitment systems out there that are doing kind of pre-screens of people through all sorts of artificial intelligence and things like that. I know Workday is a great model for HR professionals, and it does a lot of the legwork for the company. All right, it's no longer a matter of an NFL scout sitting back and making a judgment about someone. There's a whole lot of science behind sports now, and it's probably going to be a big employer of some data scientists in the future. So those are some things you want to consider. Thank you for watching our slideshow. If you have any questions, of course, you can go ahead and contact us through discussion board or through email in our class. Thank you.